thank you for coming along to this Farm Advisory Service podcast this evening. Podcast webinar, oh, goodness. But the webinar is being recorded, and the recording should end up on the Farm Advisory Service website in future. So if there's anything you'd like to go back and listen to again, you can do that, or send it on to anyone else who might have missed it that might find it interesting. So your cameras should be off and microphones muted for now. And you will get a chance to ask questions to our speakers at the end of each presentation. So if you use the Q&A button at the bottom of your screen to ask your questions there, we can put them to each of the speakers. So we've got some great speakers tonight. Dr. Elena Harris from Galbraith, who's going to be starting off with quite a broad, high-level view, looking at things on a sort of more global level, and then zooming down to a farm level and looking at farming and trees and carbon at that level. And then Dr. Mike Parks from Forest Research will be going into a bit more detail, looking at how we measure carbon in soils and forests, quantifying the role of timber in carbon, and also touching on sort of land use challenges as well. So I probably shouldn't admit this as a forester, but there was once a time when I thought that cutting down a tree was an awful thing to do. And bearing in mind that I grew up watching Blue Peter talking about holes in the ozone layer and global warming, as it was then known, as well as destruction of the rainforests. Whenever I would see images like this, forests around where I lived, being clear-felled, I thought, this is terrible destruction, how awful, why would we do this? And I didn't have any appreciation then for the fact that those trees were planted with the main purpose of being felled for a purpose. I also didn't appreciate how quickly they would be replanted and how trees are a truly renewable resource. So why do we care about carbon so much these days? It probably won't have passed you by, all the international and national targets for reducing carbon emissions. And the Scottish Government has a target of achieving net zero greenhouse gas emissions by 2045, which is not that far away. So one of the top ways we can do that is reducing our emissions in the first place. Part of that is moving to a lower carbon economy where we simply consume less and emit less. There's also elements of keeping carbon locked up where it is in some instances, avoiding unnecessary emissions, and absorbing carbon from the atmosphere, which is where we tend to think of trees playing their main role. However, trees do play a role in all these elements of reducing emissions, and I think we'll touch on all of those tonight. So it's not simply just sucking carbon dioxide out of the atmosphere and keeping hold of it in their biomass. So before we get going with the speakers, I want to get you thinking. So in the context of assuming that we want to reduce our net carbon emissions and mitigate climate change, I'd like to know a bit more about how you see the role of trees and carbon and climate change. So I'm going to run a poll in just a moment, asking whether you agree or disagree with these statements. So there's no nuance here for the sake of this exercise. It's really just agree or disagree to get an idea of what you think. So that should launch now. 4 questions or 4 statements, and if you can vote for whether you agree or disagree, and if you're not sure, go with your gut, go with whatever you feel most drawn to. And that's really just to give us an idea of what where you think at the moment, what you're thinking, and give some sort of food for thought and context for what's going to be discussed this evening. So I'll give you a few minutes to look through those 4 statements and decide if you agree or disagree. Okay, I'll close it there for now, in case anyone's nodded off or gone off for a cup of tea. And I will share the results. So hopefully you can see that. So cutting down trees makes climate change worse, even if they are replanted. So quite heavily disagreeing with that one. Using wood for building is better than using concrete and steel. Strong agree there. So maybe one person prefers to use concrete and steel. Using timber and wood products with a short lifespan, such as paper or wood fuel, makes climate change worse. So a bit more divisive, that one, a bit more evenly split. And finally, planting more trees is a good way to offset carbon emissions. Fairly strong, sort of 3/4 agree with that. So I think it's clear that there is actually needing to be a bit more nuance in these questions, but good to get a gauge of how you see trees and carbon at the moment. So I will pass on to Eleanor now, and she can start talking to us about farming in the low carbon economy.
Thank you. Just trying to work out how to dismiss the poll and share my screen. It's all happening. Right, here we go. So I'm, yeah, thanks very much for having me, and thanks for coming along to listen to me. I'm Dr. Elena Harris. I've, for the last 4 years or so, I've been working with Conifers policy researcher and been steeped in forestry. But now I've appeared in a new guise as natural capital and carbon leader at Galbraith, which is brilliant for me because it means I get to branch out forest and look at everything. One of the things I was really interested in at Conifers was integrating trees and timber growing, especially into farm businesses as part of integrated land use. And my new role is giving me the kind of scope to explore that in much more detail and in all kinds of ways. But I do come with a very much a forestry background and focus. And I've discovered that I've got almost exactly the same background as Leona, that yeah, it was trying to save the rainforest and watching Blue Peter, and that was where I was shaped as well. And then starting to ask questions about why is this wrong? What can we do better? How can we how can we live on this planet with all the people that we've got, with the amount of land that we've got, and the ecosystems we've got? How can we do that better? And that's kind of what natural capital is. That's where I've ended up. So what I want to do in my 20 minutes is, first part, we're going to start with that Blue Peter. We're going to save the world. We're going to look at the global picture and focus a bit down onto the Scottish picture and look at land use and agriculture and forestry in a very broad way. And the second part is going to be from the other angle. We're going to look at the farm and carbon on the farm, and trees and carbon on the farm, how they might fit in. And I should say, Mike's the scientist in this group. My doctorate is in history, and I'm much more of an artist. So I'm a big picture vision kind of person. Hopefully I've got some good factual content as well, but it's very much broad brush, and he'll be digging into a lot more detail of some of the things that I'm touching upon. So to start with the global picture. Farms produce food primarily, and as a world, we produce a lot of it. Per capita supply of vegetable oils and meat has doubled since 1961, and calories by a third. So we've got much more available to nourish us than we did. We waste a lot of it, and a lot of us are overweight or obese. and there are still some people who are undernourished. That's all about food system. That's discussion for a different day, but that's kind of where food is. There's lots of it about. Although I'm sure someone will point out that yields are yield increases are tailing off. And certainly when we look at the picture on the right, we can see that the world has a global agriculture carbon problem. 23% of total greenhouse gas emissions come from agriculture, forestry, and other land use, with a nice acronym, AFOLU. Obviously, that's much wider than food production. That's everything we do with land. And you'll see it breaks down. Forestry and soils is the biggest part of it. Methane is another big part of it, and nitrous oxide is another one. I'm going to stick with this AFOLU acronym. You might be more familiar with LULUCF, which is land use change and forestry. And in Scotland, we split the agriculture up from land use change and forestry. I don't think that's very helpful when you're trying to look at farm units and land use. So I'm going to kind of plump them together into AFOLU, see what happens. Land doesn't just produce food, of course. Farms don't just produce food. Farms are producing a lot more biofuel. They produce various other things as well. And the land also produces wood, and foresters are really just tree farmers. So we're producing energy. We're also producing renewable energy. We do a lot of that at Galbraith, which are all very much land-based and ecosystem-based. And we produce wood as a material. I plonked in a couple of telling graphs. One is how much wood is used for wood fuel, and you see this varies around the world. In Africa, wood is still very much used for wood fuel, as it was here 200 years ago. There was a lot of charcoal and coppicing for charcoal, and that was kind of primarily what wood, or a big part of what wood was used for, and that's still the case in Africa. They're using it to cook, whereas in more developed economies, that's much less the case. And in Europe and in North America, we don't generally use kind of leftover wood for wood fuel, but primarily we use it for making more interesting things like houses or all kinds of other materials. And the projection is that we're going to need more of it. I've struggled to find a good graph showing this, so I wouldn't pay too much attention to the numbers on that one that I did find, but it's predicted that global demand for wood is going to treble by 2060. And if you think of how forests work, you can't just turn the tap on. If you start harvesting faster than the forest is going to grow, then you start to deplete the forest very quickly. So the only way we can have treble the amount of timber is to plant treble the amount of forests. And that's the challenge that we face. If we don't do that, then the price of wood will go up, because that's what happens when you have shortages of things. And we've seen that happening just this year, because all sorts of things have happened to wood supply. Ireland has been importing a lot more of our wood than it has before, because it's got shortages. America's using a lot more wood. China's using a lot more wood as they catch up, as their economies grow and they catch up from COVID. And there's less for us. And if you've tried to get hold of any for fencing or garden improvements or anything else, you'll know that there's not a lot around, and it's expensive. And generally that's the trend that's going to continue across the world. So coming down to Scotland, Scotland's AFOLU emissions aren't quite bad as the world. They're 21%, but they're very much rising up the list, because as you can see from the graph with all the lines on it, energy has done very well at decarbonising. We've got, thanks to renewables. Transport hasn't done great, but it's coming down slowly. That should be the big focus. Perhaps it should be more of a focus than it is. Business is trickling down, and agriculture is now third on the list, and it's somewhat flatlining. So it looks likely that it's going to overtake business as the second biggest carbon contributor to Scotland's carbon emissions this year, because the figures are a year late, so this is last year's figure, although the next year might be muddled up by COVID. Meanwhile, the other component of AFLU is that green line, forestry and soil, and as I say, I've put them together. I'm going to break them down again shortly, but that is an emitter, despite although that emission hides a lot of sequestration as well. And the context of this 21% of carbon emissions, the pie chart at the bottom, is to say that agriculture, forestry and fishing is only 1% of the Scottish economy. So in economic terms, if you're a hard-nosed economist and you wanted to solve Scotland's agriculture carbon emissions problem, you'd say, well, it's not really contributing very much to the economy. In fact, it's contributing a very small amount to the economy compared to everything else, and it's responsible for all these emissions. Let's just cancel agriculture. I don't know what you do instead, but that you could imagine an economist looking at these graphs coming to that conclusion. So we've got some hard thinking to do about why that shouldn't be the case, and it very much shouldn't be the case. So let's break down that figure. And this is what we call agriculture and LULUCF, land use, and I'm calling AFLU because it sounds good. Where do the farm carbon emissions come from? A surprisingly small proportion comes from actual carbon dioxide emissions on the farm. That's the first column, and that is mostly things like burning diesel. That's where carbon emissions come from. Still, it's worth, all these emissions are worth tackling, but it's not as much as you might imagine. Methane is the second bar. So that's largely emissions from livestock, ruminant livestock. And there's some interesting, this is something that I'm on a rapid learning curve about coming into farming, and it's very interesting, but there's no magic bullet for that as yet. Nitrous oxide is the third column, and that's also a big issue in farming, coming from fertilizer, rising fertilizer use. How can we change that trajectory? Again, something to be tackled. But then we see soil carbon dioxide emissions is the next one. And suddenly you've got a huge bar, and that explains why the Scottish government is so interested in peatland, because most of this and most of the next one, which is methane from soils, most of those are coming from degraded peatland. And that's that. I think this really explains Scotland's policy focus. And then finally, again, Scotland's policy focus on trees. Trees are providing a really significant carbon sink, despite the fact that around 19% of Scotland is forested. It's providing a carbon sink that there's nothing else like it in the economy. There's no other bar in the carbon emissions graph that goes that way. Trees really are, if anything's a magic bullet, then the Scottish carbon emissions suggests that trees could be it. But it's let's look at that 1% of the economy thing. What should we just cancel Scotland's agriculture, plant everything with trees and walk away, lock away the key, go back to our cities and get on with the economy? Well, obviously not, because we'd have nothing to eat, we'd have nothing to build our houses out of, we'd have no stuff, and any stuff we did have would have to be dug out of the ground. And so this is where I want to bring in the concept of circular economy. I've seen various circular economy diagrams I didn't understand, so I've drawn my own, which is much simplified. But in general, you'll see the cow at the top, that's farming. In fact, let's not start with the cow at the top, start with that pile of bars of gold. Bars of, that's my mineral materials on the top right, which produce various things we need, clothes and buildings and technology. And they come to us as the consumer at the bottom. And in the circular economy model, we're not consumers of those things, we're users. So these things pass through our hands, we use them, when we finish with them, we pass them back and into industry, and industry sorts them out in that closed loop, and industry sends them back to us as new things. So instead of throwing things to landfill, single-use plastics are perhaps the prime example of this. Everything is in this closed loop, and that's one half of the circular economy. But it has another half, because obviously there's a lot of things that you can't use circularly. Most of all, food. Once you've eaten it. But as seen earlier, quite a lot of it ends up wasted, and it's all produced. It has to be produced continuously from the ground. So the circular economy, another important component of the circular economy is regenerative production, which is very hard to say. And so that half of the loop is in this regenerative cycle, which means in the production of that material, rather than degrading the land you're producing it from, you're making it a better place. So as you produce, you are sequestering carbon, you are creating more biodiversity, you're leaving the land in a better state than it was. And in natural capital terminology, you're investing in the natural capital so that you've got a richer natural capital asset from which to produce in future, rather than depleting it as we have done. The tree in the middle it has a bit of a special place, and I've never seen it in a circular economy diagram, so I've stuck it in here for any circular economy people listening. Then I hope you will take note and stick it in, because the tree is both regenerative and can be circular as well. You can use timber, and we call it cascading, so it's almost circular. You start by using the timber for for things like you can produce modular housing, which can then be reassembled like Lego bricks into other houses. When it starts to degrade, you can turn it into things like panel board, or perhaps clothing. You can make clothes out of wood fiber, and then at the end of life, you can always burn it for energy, or it returns in that regenerative cycle to some form of enhancing the land. So how we use materials in the circular economy in forestry becomes absolutely at the heart of it. But what this generally implies is that instead of being that 1% of the economy, that agriculture and forestry should be absolutely at the heart. They're such a core part of the circular economy, and they're in fact the only thing that's providing new inputs. So yeah, if any economist ever says that to you, it's to be rebuffed. That's enough big global vision. What's this actually mean on the farm? And I've used most of my 20 minutes already. So next bit kind of rattles through. It was clever, I'd have animated this. So carbon on the farm. If you've got a farm, you've got land, you've got the only thing that can do carbon capture and storage. Plants capture CO2 from the air and capture carbon from the air, turn it into plant. That's what they do, and all kinds of plants do this in much the same way. But it doesn't necessarily stay in plants. It might stay in a tree for quite a long time, but eventually it will turn into beetles that eat trees, or fungi that eat trees, or turn into soil, or we will cut it down and turn it into houses or clothes or whatever else we turn it into. Other plants, we might eat them ourselves, and the carbon turns into us, or feed it to animals who they're made of carbon as well, or it might be biofuel that we use to do things with. And of course, in many of these, it gets lost again. So if we eat carbon-based plants, then we eventually breathe it out again. And as do cows, who have a bad habit of turning it into methane as well. If you burn it, obviously the carbon returns to the air. And it can also decompose. So those processes, decomposition, respiration, and burning, kind of undo the work of photosynthesis, and that's the carbon cycle. And of course, in the process, we're doing a lot of other things to achieve that photosynthesis, which is what we're all about, which also emit extra carbon. So whether that's running machinery on diesel, or whether it's adding nitrate fertilizer, or whether it's that methane that's being produced by our livestock, that's adding extra carbon up above and beyond what our what would otherwise have been a closed loop of photosynthesis, and that's where the real problems start to lie. So the farm carbon challenge of that is that 21% carbon emissions is how do we get more coming down than is going up, and that's where farming land use has the opportunity to be not just make its problem less bad, which is what all the other sectors do, but to actually reverse the problem, because we're fundamentally using these magical plant machines that are capturing carbon. So we could do that by increasing the store, building ecosystems, planting forests that stay there, that build forest soil, also by using trees in long life products, which kind of create a, if you imagine a timber city with lots of timber furniture and people using timber products and wearing timber clothes, that's as good a carbon store as a forest. And if some of it's lost in the end through decomposition, well, that's kind of the same. You've kind of expanded the forest into the city. And your building soil is something that can be done across the farm in all sorts of, it's not just in the forest. That's regenerative agriculture. And also reducing the emissions, being more efficient with machinery use, reducing diesel, reducing food waste, sort of begins on the farm, reducing nitrate use, methane, reducing diets, slurry management, cleaner burning, peatland restoration. I'm going to mention these again at the end, but it's not the focus of what we're talking about today. And how do you do that? That's this is natural capital management. There's all kinds of techniques for doing this, and part of the challenge for us and for policymakers is to find the ones that are going to be the most effective. And if you're running a farm, then the key thing is it cost effective? Is it going to bankrupt you, or is it going to enhance the farm business? There's lots of ways that reducing carbon can enhance the farm business. Lower inputs is a really obvious one. If you're using less, you're paying for less. Market access, if supermarkets are starting to call for zero carbon food, which they are. New products, timber is one of them. Ensuring compliance and carbon offsets, which I'll mention shortly. But it also costs money, and there's no point pretending it doesn't. It can result in lower yields, higher input costs, often a lot of capital expenditure and considerable risk. So what do you do about it? Well, we at Galbraith have been trying to work out the key interventions, and I've kind of brought this from my previous policy role, is looking at what the key policy interventions are. They go together, and one is carbon offsetting, and there's both peatland and woodland. Woodland is far more established, and Mike's going to talk more about this imminently. Peatland also very interesting, and if you've got deep peat, then there's chances are there's not a great deal else you can do with it. Carbon offsetting is a real opportunity, and something not to be missed, and it's something that more and more people are coming and asking us about. Timber, of course. I don't know why I got onto this so late. I should have done the whole presentation on timber, but I really wanted to put it into that context of the whole system, and how essential it is to the circular economy. And government is, again, it's seen as something to support. So they're supporting increasing Scottish timber production, and it's its advantage for a farm business is, whereas carbon is time limited, you're creating that ecosystem and you're paid to create the ecosystem. But once it's created, that's kind of it. You've then got what do you do with it? Growing timber is keeping land in production, often the least productive land, and will do in perpetuity. And as I said, timber's very valuable. You can grow, I reckon you can grow 1 or possibly 2. We're having some arguments about how much timber you need to build a house, but 1 or 2 timber frame houses every year per hectare of forest that you're growing. And as you'll know, if you've been trying to get hold of timber, then people will pay good money for that. And I think people don't quite know how much timber how fast it grows. It's pretty speedy growing stuff. That on the top top right, I am nearly finished, Leona. Top right is what high quality timber in Scotland is used for. So about 40% of it does go into construction, and a lot of the rest, most of the rest, is going into the farm and food system. So it's fencing and packaging and pallets. So it's not going off to some mysterious other place. It is really core economic uses in the circular economy. That graph at the bottom right is my model, that I think it's fairly well evidenced of the carbon benefit of forestry. And the bottom orange line, carbon credits, that's what you'll get. You can sell if you're growing a forest for carbon credits. That's what the carbon credit system will tell you that your carbon benefit is. And as you'll see, it rises up in the first 20 or 30 years and then starts to flatten out as your trees slow down in their growth. This model that I've got is 50% broadleaf, which you can see growing at the bottom. It is more or less actually the same as the carbon credits. But then there's a 50% harvested component, which is actually providing carbon credits, not really showing up. And you see that zigzags up and down because every so often you harvest it all and take it all out of the forest. So they're not growing in the forest anymore, but it doesn't go away. It turns into wood products. And in this model, the wood products degrade over the course of 30 or 50 years before being replaced by the next harvest of wood products. But the interesting bit that is very abstract, and I wanted to show in the brightest color, is the emissions that you avoid by not using concrete. So at the point where you harvest the trees, you take them away, you go and build a house with them. At that point, you don't emit a whole load of carbon, which you would have done if you'd used brick and block for the house. And those carbon emissions are never emitted. That carbon benefit never goes away. So you never need to offset them with trees. You never need to worry about them again. You've not emitted them. And that's quite hard to get your head around, but that's the really big carbon benefit of timber, which is perhaps not adequately rewarded. But forestry, as I say, is very well supported and financially great opportunity. And the final thing I wanted to mention, it's not trees, but what about all that other stuff? Well, that's why we're working on natural capital assessments and farm carbon assessments. And that's really looking at the integrated land use that I was talking about, because not everywhere is suitable for trees. Some places are suitable for trees, but you might not have thought about what kind of trees you want. And there's all kinds of other opportunities for reducing carbon, increasing nature, making money on a farm. And so that's the other big area of my work at the moment, is that integrated look at the land and where the opportunities are. So apologies for overrunning. And just finally say thank you very much, and do get in touch if there's my contact details if you would like to ask about any more of that, but you can also ask in the discussion. And now stop talking, stop sharing.
Great, thank you, Eleanor. That was a good whirlwind tour from, yeah, up in the atmosphere, looking down onto the farm. So we've got a couple of questions already. Anyone else want to ask some questions, please pop them in the Q&A box. So we'll see if Paul Gill would like to ask his question. You should be able to unmute yourself, Paul.
Hi, Eleanor. Lovely to see you in your new role. You're looking great.
Hi, Paul. Thank you.
So congratulations on your new job with Galbraith. I've been looking forward to this event for a long time. Your slide that showed 21% of greenhouse gas emissions coming from 1% of the Scottish economy gives the target for the agriculture and forestry sector very, very clearly, and goes against the findings of the first poll, which suggested that cutting trees is not generally, even if they're replanted, the best solution, assuming we have to pick just one. It's obviously part of the mix, but it is not the best solution to mitigating our greenhouse gas emissions, particularly when we, as we are now, increasingly including nitrous oxide, laughing gas, and our methane emissions, which when I was Friends of the Earth's climate change advisor in 1992-93 and supplied a review to this effect, available to anyone on request, 2 reports from Friends of the Earth's library, methane and methane and nitrous oxide were clearly going to, this was almost 30 years ago, self-evidently, at least to me, the solutions we would be looking at now. So I guess my question relating to long-lasting furniture and recyclable clothing. So I guess my question is, how can we encourage policy and practice for long lifetime furniture and clothing products from agroforestry? That's my question.
That sounds like a lot of things to do at once: agroforestry and clothing and furniture. And the challenge, and this is a kind of a question about, well, this gets into territory about the nature of the global economy, is that we do live in a world of big scale, and things are done at scale. And we're kind of, I'm a kind of, rather than designing the perfect system, I like to say, let's look at the system we've got and how can we improve it. And given that we've got a world of big markets and big scale, what can we do in Scotland with the kind of land we've got and the scale of industry we've got? What should we be producing here? What should we be trading with the rest of the world? And I suspect it would be lovely for Scotland to be kind of self-sufficient and producing all the clothing and food and housing and everything that we need. But actually, that's
sorry, Eleanor, furniture is what I'm focusing on, and there is a small and potentially growable hardwood and to some extent pine furniture industry. And since we are the biggest importers after China, that is not per capita, that is absolute. So we import more timber than the United States, with Germany, France, Italy. Surely furniture is what we should be focusing on.
Well, I don't think most of it is furniture.
No, I agree. We're not importing furniture, but it's a part of the mix.
It's a part, yeah. It would be, I associate furniture with beach. I think I'm sitting on a beach chair. It's the kind of furniture you're talking about, I think. And it's beech, perhaps not an ideal Scottish species, but certainly in the rest of the UK, it's a species that it grows very well. It forms very nice wood, but it's very hard to find a use for. But actually, the world is struggling with this. Germany is finding it difficult to find a use for beech. Hardwoods are a real challenge, and yeah, England is very English government is very keen on the idea of growing more hardwoods and using it for more things. But oh, we're getting a bit of interference in here.
Sorry, there's people talking in the background.
How do we use diverse species for diverse things? I guess in diverse, we want to have integrated land use is all about diverse land uses with mixtures of things. I'm not answering the question at all, but I think it is at land use level, we do want lots of different things going on. How do we mix that up with an industry and an economy that wants large amounts of one consistent product? So yeah, I don't know I'm not sure what the answer is, but I think finding that, I think the way that we are approaching it in Scotland of ensuring that every forest does have diversity, including diverse commercial species, and encouraging forestry on farms rather than just in a very old-fashioned way of the Forestry Commission buying up large tracts of land and planting it. That's perhaps starting to develop things in the direction that you're aiming for. Sorry, it wasn't a very good answer to the question, but it's very interesting themes.
Thank you, Eleanor. I hope that answers your question, Paul. And we have another question from Can. If you want to put your question to Eleanor, if you're there.
Thank you. Thank you for the nice presentation. My question is just a simple one. It is about plantation, like agroforestry or other plantation on the community land, which are these days have got much much attention to restore the land, the degraded land. So can we, as we know that the plantations are mostly for commercial purposes, after a few years they are being harvested. So still can we take it as a carbon sinker? Because after a few years when they are being harvested, they again turn into carbon emissions.
That's a very good question. If you didn't catch it, I think, you're asking how can there be carbon sinks when trees are harvested and then turned back into carbon emissions. This is, I think Mike's going to cover this in a bit more detail, possibly, but I think that the important thing is timescale we're talking about. And obviously, if you're growing trees, you're not creating a geological carbon sink. It's not like putting the oil back in the oil wells. Forests are kind of by nature transient, and whether it's a forest that's growing or a forest that's been harvested, a growing forest could burn down potentially or be killed by some nasty beastie that we've seen a few of ravaging various, like our ash in Scotland is becoming a significant emitter of carbon as the ash trees are dying and decomposing again. If you harvest trees, obviously they're not there. My argument would be if you, as I was saying, I've got this kind of vision of a timber city. So if you grow a forest, you've got one lot of trees standing in the forest, you harvest them, you grow another lot of trees, but meanwhile, your first lot of trees are still there, they're in the city, forming houses and all the other things that we're using. And yes, timber is being lost from the forest as trees die and break down. Timber is being lost from the city as things degrade and eventually maybe burned. But what you've got is a big and potentially quite fast growing store of carbon if you start to replace the stuff we use with timber stuff, and you're using then your forest, rather than becoming a one-off carbon sink, it becomes a carbon pipe. It's not the trees standing in the forest is not the final thing. That's actually the place where you're doing the photosynthesizing, and by removing the trees, doing something else with them, you're increasing the photosynthesizing by keeping the trees growing fast, and that's not it's not going to it might not solve climate change for the next million years, but actually we're not worried about the next million years, we're worried about the next 50 and 100 years. I'm worried about climate change right now. So growing fast-growing trees for creating timber is the fastest way we've got really of drawing down that carbon from the atmosphere. And then if we can keep it for a few decades or maybe a few centuries, then that buys us a huge amount of time to look at potentially wider aspects of how we look after our global climate.
Thank you very much.
Thank you for your question.
Great question.
Yeah. We've got another question from Jenny Cowan. Jenny, would you like to ask your question?
Hello, thank you for your presentation. It was great, really, really interesting. My question is, as a farmer, I find carbon audits, the farm carbon audits presently really frustrating as it doesn't take farm woodland sequestration into account. How can we improve that to make a more holistic farm audit, including things like the peatland restoration and that sort of thing?
That might be a question for Leona, but it's certainly, it's how we're thinking about this at Galbraith, and I would certainly, want to see it as in a holistic way. And Leona.
Yeah, definitely. I mean, some of your graphs were really great, and how does the timber sequestration and storing of that carbon in the timber compare with regenerative agriculture, soil sequestration and grassland? Is it a huge difference, or
put me on the spot on numbers. I think I'm not sure about pace of I think essentially trees will sequester carbon faster than like soil carbon regeneration. The difference with soil carbon regeneration is it's generally over a pretty big area. Oh, Mike's going to come in and rescue me. Go on, Mike.
Hi there,
Well,
Mike Brooks. It's scales of magnitude different. If you just simply envisage a wooded landscape, a forest, and you think, well, how might regenerative agriculture manage to put that much carbon in the top few centimeters of soil? It's physically not possible. It's an order of magnitude different.
Okay,
Cool.
And you were saying, does forestry store more carbon in the soil as well as within the timber product?
I'm not quite getting your question. So there's
more.
Yeah.
Grass will, and all the microbes in the grass will pull that carbon down into the soil. Do trees do the same thing but on a bigger scale?
Over long time scales, yes.
Yeah.
Is the answer. Not over short term time scales.
I haven't seen very clear. Yeah, these are really good questions, and ones I am also trying to get my head around. And I think actually the people at the forefront of the research are also still getting their head around. One of the interesting things about the new environmental land management in England is they are very interested in this soil carbon, and because England has much more arable farming than Scotland, so it's a higher priority for policy. I think we'll be able to pinch ideas from them, and they're looking at doing a lot more farm regenerative agriculture and growing food in a way that puts carbon back in the soil. I think it's not either or. The land that we're not using for, obviously we're going to be growing food in arable landscapes. While we're doing that, let's do that in a better carbon management way. But I think at the moment it's and we're at Galbraith, we're very much looking at, since that's not part of government policy, where are the incentives? And there's quite interesting moves by supermarkets and other food providers to start to decarbonize their supply chains, and that might provide opportunities for doing a lot more with agricultural soils. But yeah, what Mike says I think is true. If you want to, if you've got a minority of your land where you could grow trees, and especially trees that grow fast, then you can kind of wipe out your other carbon emissions, and you know, that's where the big win is.
Yeah, definitely. Thank you very much.
I don't know if well, I don't know if Leona wants to respond on the
Yes, to go back to your initial question, Jenny, about
carbon audits.
Carbon audits. I don't know what your previous experience of carbon audits has been, but I know the Farm Advisory Service offers farm carbon audits using a tool called AgriCalc, which I believe, I'm not an expert on it myself, but my colleagues are doing a lot of work at the moment, improving it and making it more detailed. And I believe it does include farm woodlands, but we're certainly trying to work on making that more detailed and more accurate. And I think including, you know, trees outside woodlands and hedgerows and you know, all the kind of finer details of carbon as well. So that's something I was going to speak about at the end. So I'll mention it again at the end after Mike's presentation, but that's something to bear in mind if you haven't had a look at those already through the FAS website.
Yeah, I will do.
Okay, so if we have any last minute questions for Eleanor, or can she have a breather perhaps? I think we'll call it there and let Mike take over. You ready, Mike?
Yeah, I'm just sharing my screen. Hopefully that's come through.
Here we go. Take it
Yeah,
away.
we're good to go. Thanks very much. Well, hello, welcome everybody. My name's Mike Perks. I'm a scientist at a government research institute called Forest Research. Since devolution of forestry management and forestry policy, we're the only GB bit left of what used to be called the Forestry Commission. So my science knows no country borders, although I do tend to focus in the northern half of the country. I'm standing on the shoulders of giants and colleagues in the information that I'm presenting you today. So I've been asked to present on understanding the carbon balance of forestry. How do we know what the carbon is in the soils and the carbon in the trees? How, where and why do we manage it? And what might we do to maximize forest carbon sequestration? I'm drawing upon an analysis which is quite recent, working with colleagues in James Hutton Institute and the University of Aberdeen, which had a very Scottish focus, looking at the trade-offs and benefits of different forestry types in delivering towards the Scottish Government's ambitions for net zero in 2045, which in a tree-focused perspective is a really short time. So woodland carbon stocks are key. Understanding the soil carbon is key to understanding the options for land management. And we have a soil classification system where we have a lot of soils which have a mineral basis. They don't have any organic material. They don't have any peat, or they're not PT. And the soil carbon stocks in those are all pretty much the same. And then we have the PT soils, the mustard coloured bar here in the left chart. They have a much higher soil carbon stock. And then we have the deep peats. And the difference between these two is the PT soils, you just have a small layer of organic material, whereas the deep peats, as the word suggests, could be meters of carbon. And when we look at the contribution of that element to the total carbon stocks in UK woodland, soils account for nearly 70%. And so we need to be very careful about what we do, particularly with the high carbon end of the soil spectrum with respect to woodland. How do we know that forests are good as carbon sinks? and stores, well, really, that balance, carbon sequestration, is a balance between the activities of photosynthesis, using sunlight energy to turn carbon dioxide into sugars, and then turning those sugars into wood in the case of trees, or grain in the case of barley, versus respiration, which is the respiratory losses that come around because of that process. And we need to, those are not always in balance. But the fundamental here is that we need to understand those processes to see how the system interacts with the climate. And that's really what I kind of do for a living. So here I'm going to introduce a concept called net ecosystem productivity, or NEP, which is a measure of the exchange between the land surface and the atmosphere. And it doesn't matter what's growing on the land surface. You can measure NEP if it's an arable crop, you can measure NEP if it's a peat bog, and you can measure NEP if it's a forest. It's just a bit more difficult to do with trees because they're tall. But basically, we have a system of instrumentation which allows us to measure the uptake and loss through photosynthesis and respiration of all the components of the forest. That includes the soil components and the tree components. So you can see here we have some downward arrows and some upward arrows. And when you measure this, you do it at very high resolution. A lot of measurements, 20 measurements a second, some of our instrumentation. And if you're doing it in a forest, then you have to measure above the canopy. So we have two forest research platforms, one in a oak-dominated broadleaf forest, that's the slide on the top left, which is in Alice Holt in Surrey, and one in a commercial conifer plantation, that's the slide on the right, and the towers are at about 30 plus meters tall. And we use a suite of instrumentation and some very clever maths and physics done by people much brighter than I in order to calculate that CO2 exchange above the surface. We can also, of course, go and measure the trees. And by measuring lots of trees, you can come up with equations that explain the taper of the tree depending upon the height, how much it's likely to grow in the next year, and you can therefore attribute the proportion of that growth that is actually carbon. And so and we try and make sure that these two measurement systems match. And when we do these measurements, particularly the two sites the kinds of sites I've just shown you, then you can see the green is actually the NEP. So that's the net ecosystem productivity. That's relative to the climate, how much is being lost under the line or taken up over the line. And we can compare it. Top graph is for a commercial conifer forest. Bottom left graph is for this oak mixed deciduous forest. So in the case of the conifer, even in the winter, you can get some positive spikes because the temperature is the thing that limits an evergreen tree from taking up carbon. For a deciduous forest, we get losses where for all of the periods when the tree is in leaf, and we get gains for the period when the woodland is in leaf. And when you sum these up, you get the black line there. And so you might be accumulating 25 tons of CO2 per hectare in a conifer plantation, and you might be accumulating 15 or so in a mature oak mixed deciduous plantation. But over and above this, oh, sorry, I've gone too far. And then the importance of the soil. So we also need to understand that if we take a landscape and we disturb the soil in order to plant a forest, then there'll be losses because of that disturbance from the soil carbon. And these are being modelled by people. This is from Paul Jarvis and Edinburgh University. And we've got the measurements here of NEP, and we've got the losses from respiration in the top graph, and at the bottom we've got then the soil loss over the first rotation, but then we tend to put carbon back into the soils in the second rotation. And so after 2 rotations, the soils are about where they started, but what we've got is all of this tree and timber carbon that we've managed to produce over and above if the soil had been left in its original state. So that's a win. If we then account for where the materials and or fuel substitution from biomass goes, then we can look at cumulative abatement, the top graph on the right hand side of your screen. So the sequestration is what's coming from growing a forest. The top one is growing a forest that's not being thinned, not being managed, not being felled. The bottom graph is a forest that is being thinned and felled over a number of decades. But the important thing here is that the substitution benefit is adding a considerable amount to the overall picture. If we substitute for fossil fuels, currently, if you're using biomass for bioenergy, you're getting about 0.67 tons of carbon avoided per ton of carbon from wood combustion, because you are effectively replacing a proportion of oil-derived energy production. As we decarbonise our electricity supply, that number will drop. But at the moment, it's still a positive. If we look at long and short-lived harvested wood products, then here we have structural construction. Maybe you've got 1.3 kilograms of carbon per kilograms of wood product in terms of a substitution effect. If we go down and see textiles, so we're using the wood bioeconomy to create lignocellulosic feedstocks to replace plastics effectively, then we're getting a very good return. So this broader aspect of how do we upscale from a wood-based lignocellulosic feedstock to provide products that remove a requirement for oil is all part of the picture. And of course, there's lots of ways to manage a forest. We can go everything from a nature reserve with very little intervention through to creating by short-lived high production wood for biofuel. And if you take these different sorts of representations of forest management and you combine them with land use and soils modelling, the ECOS model in the black box in this slide, then we can look at the potential net uptake on site. This is not including the substitution benefits at the moment. And we can do it for these sorts of different types of management. So on the left, we have a native conifer, relatively slow growing. The blue areas are high carbon. Obviously, it's quite a large extent that can provide you reasonable carbon returns. Whereas on the right-hand side graph, this is a production Sitka spruce, where there's less area that will create the very high carbon gains, but the carbon gains are much higher for that particular management choice. And here we've got a suite of them. So down at the bottom, we've got native conifer, native broadleaf. The coloured bars are the number of years you've had that woodland. And so you can see, here's the zero line. So anything to the left of the zero line, that's because your soil carbon losses are greater in establishing that woodland than the gains you're getting from growing the tree. And it can take you 10 or more years to get that back. Whereas for the more productive classes in the sort of middle area there, the productive conifer, Sitka spruce, we have even at year 20, we're in credit, because the trees are growing fast enough to have offset the disturbance for the soil carbon. If we then do an analysis based on land class, recent research, which we've placed fewer restrictions on where we might consider forestry, shows that there's a lot of agricultural, current agricultural land that would be available for and suitable for woodland planting. This new assessment includes new land capability filters, new peat extent data, because we're avoiding planting on deep peats, and new NFI data. So we're not planting trees where we've already got trees, effectively. Technical that. So if we run this analysis, and we're looking for areas which will deliver at least 0 tons of carbon, so they'll have restored the soil losses to disturbance. There's quite a lot of land available that does that across all of the different woodland types, irrespective of the previous land use, which are the 3 right-hand columns: semi-natural land use, grassland, including improved grassland, and cropping land. If we try to deliver higher levels, which match with the government's ambitions for net zero 2045, their cap in their system for forestry is forestry should deliver this 1 tonne of hectare per carbon per year over 20 years, then we see that the lower production options at the top here, they all fall out because they don't achieve that between now and 2045. That doesn't mean we can't do them. But what it does mean is we have to focus on some of the more productive ones, the sort of oranges and greens here in this graph, and move those trees onto the improved grasslands and cropping lands, because we can over-deliver there, and therefore we can afford to do upland rewilding, native broadleafs, etc., etc. But fundamentally, the native broadleafs in the short term don't deliver to the government ambition. How do we incentivize new woodlands? Well, at the moment, there's realization that forests are a reliable way to lock up and store carbon. They're a cost-effective abatement strategy or mitigation strategy, and there's many co-benefits in terms of habitats, biodiversity. I'll come on to a few of them more on the farm-based bit of my talk. And the government, therefore, does support woodland creation and across multiple different categories, across multiple different land capability for agricultural classes. And they've developed a process where you can get a carbon credit for the accrual that your scheme will deliver. And that is additional finance to help you make that decision to fill the gap where the grant aid doesn't quite reach. And there's rules here about how that finance is being seen as to be additional. And there's also an issue there where they have a mechanism whereby the permanence of that developing carbon store is maintained. It offers clarity and transparency to customers and land managers. It's a framework which is relatively simple to understand, and it reassures the market investments about the voluntary carbon that they're buying. It's a voluntary standard, voluntary scheme. So how do we get trees to come down the hill and into the agricultural landscapes? Here we're not talking about replacement, we're talking about integration. And the catch-all phrase here is agroforestry. There's a report there from the Climate Exchange, you can obtain it online, Agroforestry in Scotland, which has a very carbon focus because I wrote it. Fundamentally, agroforestry provides options, provides shelter, reduce feed costs, improve welfare, which can reduce soil erosion and diversify income. Again, as in the last graphs, the type of forest and the extent of forest you choose scales to the amount of carbon you're going to achieve within your land holding. Currently, grant support under the existing grant aid schemes restricts agroforestry to agricultural classes 3.1 to 4.2. I think that will change, but I don't know. Integrating land use thinking by land managers, thinking of forestry as just another colour on the palette is really important, as is supporting that move through grant aid, simplifying options and payments. So whilst the Woodland Carbon Code provides additional carbon finance, all types of woodland are eligible. The return on investment is good. And the profit from felling, if you grow commercial species or broadleafs, including aiming for quality timber from broadleafs, is exempt from capital gains tax. Currently, productive woodlands are about a 10% plus return. They provide other benefits. Woodlands slow runoff, counteract soil erosion, can be used to reduce ammonia emissions, particularly from sort of poultry and pigs, and in by housing for cattle, and improve visual landscape character and the like. So here, back to the key point here, the better quality land delivers the higher carbon benefits and likely the better economic returns. And shelter belts are particularly useful in here. So it's not a large land take, but that enables us to come down the hill, and they provide these other ancillary benefits. So if we look here, we've got from the lowest LCA quality land, sixes and sevens in purple here. They might deliver some benefit, not if they're on a peaty soil, not in the time frame that government's really interested. Whereas as we come down to improved grassland and mixed agriculture, then the delivery is much higher. So my final point, it's important, the importance here is the soils. As we started in the talk, the stock in the soil is large. So we want to avoid cultivation practices on high carbon soils that increase soil carbon losses. That includes drainage. And peaty soils are a particular concern. But on rotational grasslands and arable landscape and more traditional arable landscapes, you typically have low carbon content, so there's less risk, and there's more likely of high levels of productivity. I'll finish with a note from the previous Forestry Commissioner Leeds chair, Sir Harry Studholme, which he made a very valid point, which is timber of oak is more dense. It sequesters more carbon per cubic metre of timber, but there are many, many more cubic metres of timber in a conifer plantation than there is in an oak forest. So if we're certain about being robust about the climate emergency and how land use can help deliver, we have to look across all the options. Thank you very much.
Thank you, Mike. That was another whirlwind through the science and the detail and policy and Woodland Carbon Code and everything. So lots covered. We haven't had any questions yet, so get them in through the Q&A box if there's something.
I'm sorry, Paul, if you were struggling to see the slides. If I'd had my chat up, I would have had a go at changing that.
I think it was only, I don't think anyone else had problems, so I don't know if it's a problem
because he's on his phone.
Paul's end.
Yeah, maybe just because he's on his phone.
So, and I did say to Paul that the webinar being recorded means that you could watch it back on the FAS website at a later date if you've missed anything.
Excellent. I'll dip into Jenny Cowan's question, because the farm audit side. Certainly, I'd discussed with Bob Rees about updating the farm tool that Struck advisors use to improve the woodland sequestration element. It is in there already, but it's very basic. But we're looking for funds as a way to deliver that improvement.
Yeah, good to hear. I think that's definitely on my side of things as well. That yeah, we're working on improving it all the time, and I think not just the woodlands element.
Yeah, sure, it's an ongoing process. Jenny, how carbon managed with biodiversity collapse? Well, it's very interesting. We've done some work recently for the Greater Glasgow local authorities, where we've mapped not only the carbon potential on for increasing woodland cover, but we've also added the nuance there as to how best to make habitat corridors and habitat networks, woodland habitat corridors and woodland habitat networks. So therefore you're trying to deliver twice. I think the other important thing here is that we have to be very careful about site selection. Whilst I can create a map that says where forests could go, you have to have knowledgeable local people with local knowledge, because we don't want to plant on a rare acid grassland that's good for a particular butterfly or some such case in point. And so the local scale assessment of suitability is also of primary importance. But in the UK, even in Scotland, Scotland is, what is it, 18% forest, maybe 19 now. We're the European average is above 30%. We're way behind. So there's plenty of space, there's plenty of opportunity. We've just become used in large tracts of Scotland we've become used to seeing a unforested landscape. And really, in terms of biodiversity, some of those unforested landscapes are pretty much deserts. So what are we doing? It's a rhetorical question.
I agree. I think we've had trouble recently with not trouble, but balancing. We've been wanting to do quite a lot of woodland. We've got a massive commercial woodland. We've just put in a partnership with next door, and we had 3 smaller native woodlands never to be harvested as a kind of balancing act for the biodiversity. And we had 3 years to get that through forestry planning, whatever you call that, and all the surveys and stuff. And actually none of the native ones went ahead because of ring ouzels living in the gullies we were wanting to plant. So it's and I think a lot of the commercial stuff got made a lot smaller because of sight lines from paths and that sort of thing. So it's this whole balance of everything, really, isn't it?
Yeah, there's always a local consultation as to any sort of proposed plan for planting.
Can I chip in on that one as well?
Yeah.
I'll do a plug. When I worked for Conifers, I wrote the Conifers report on biodiversity, forestry and wood, which was essentially a literature review of what research has been done on on the biodiversity in forests, because it seemed to me that a lot of there was a lot of kind of lazy debate around native woodlands are good for biodiversity and commercial woodlands are bad for biodiversity. And so I've dug into with lots of my ex-colleagues at Forest Research have actually done a huge amount of research on this, and especially going back 10 and 20 years as the UK Forestry Standard and the UK Woodland Assurance Standard were being developed and improved on how do you what is the effect, good or bad, of forests on of the kind of new forests that we create for timber plantations in Scotland for biodiversity. And there's sort of several elements. One is a tree is a tree, and there's a huge amount of woodland biodiversity which will happily be supported by all kinds of trees, and that's why plantations on ancient woodland sites are important sites. It's not that the replanting of those ancient woodland sites with conifers, which now we would find we wouldn't do that now, and quite rightly, but the actual planting of those sites with conifers actually retained a lot of the important biodiversity, which is why they're now interesting sites, whereas other ancient woodlands were simply cleared and lost as woodland, and they're not there at all. So any wood has some useful biodiversity. And then another issue is what land are you replacing? So as Mike was saying, we're now very careful about where we do plant woodland. And as I said, one of the nice things about Galbraith is getting to work in integrated land use. And it's the forestry department are taking over peatland restoration, and forestry and peatland restoration are often kind of like this in the landscape. There comes a point where you don't want to plant commercial trees anymore because it's becoming interesting. You plant some native scrub maybe, and then you get to the bit where the peat's too deep, so it's not going to be good for soil carbon, and that's the point where peatland restoration becomes the best option. It's actually all part of the same landscape, and then you've got one kind of designed landscape with different types of habitat. And then finally, what good is a commercial plantation on open land? You haven't even got you haven't got that ancient woodland ecology. Well, actually, if you plant any kind of trees on land that wasn't trees before, you risk creating something that is just a bunch of trees on a bunch of land, whether you plant native trees or commercial trees. So, I think there's some thinking to be done about the kind of native woodlands that are sometimes created, and how we, then finally, there's the kind of maturity of the trees. Much of the forest that we see in Scotland is still very, very young. In forestry terms, we had, 4% forest cover 100 years ago. I'm getting my figures wrong, but, we've increased massively over the past century. And obviously those woodlands, and they're older than a century, so they haven't developed the woodland ecology. But we know that things like wood ants will move into conifer plantations. They just do so at a very slow rate. So they're still kind of working their way through. So that whole, it's really important, carbon and biodiversity, but generally trees are pretty good for both. And it's good to hear you doing some really creative thinking about how we do it in a more intelligent way, rather than trees are good or bad and conifers and broadleaves are good or bad. It's much more complicated than that. And I think we're getting smarter at understanding this, joining up the policies, I hope.
Yeah, definitely. I think that the way forward is a mix, isn't it? It's a mosaic rather than a blanket of anything, really. Yep. So I think that's the really exciting bit, really, about agroforestry in many ways.
Yes.
Yeah.
Are you doing sorry.
Right tree, right place for the right reason. And if it's none of those, don't do it. If one of those falls down, don't do it. There's a better thing to be done with that bit of land.
Yeah, it's a good mantra. We did have another question from Pippa Hodges. It was quite a similar question, but I wonder if Pippa, you want to have a chance to ask as well. If you're there, Pippa.
Hi, can you hear me?
Yep.
Yep.
It was exactly the same question as the one you just answered. So thank you very much. I think I've had it answered for me already.
Very good. I think the large scale in your question in the chat is interesting, because I think the large scale blanket afforestation isn't going to happen. Not in this round. It's not going to be the same level of ambition. We're talking about large scales as in tens of thousands of hectares per year, but I don't think we'll be getting a lot of schemes which are thousands of hectares in a scheme, because we want to have this integration in the landscape. And if you're coming down the hill, you're not going to get that large areas given over to commercial conifers or native broadleafs or whatever. Even in the design of plans now, there's restrictions on how much of any one type you can have. And so all these, there's more nuance and balance in what you can do now.
That's good to hear.
Yeah, and I would add to that I don't think I've seen the figures for this latest year, but in grant funded woodlands, think the average scheme size is about 24 hectares. So really much more concentration on these integrated farm woodlands rather than, yeah, gargantuan blocks of forest. And I think, it's easy to see all the mature forests that are on that sort of scale and think that's where we are. But it's definitely not the way we're going from what I can see.
It's again, I think there's sort of two sides to this story, and there's we've talked a bit about integrated landscapes and connected landscapes, and one of the bits of research I came across, and I'd have liked to know a bit more about this, but it was about the value of a large scale forest, and that if you have, once you start to have a widely afforested landscape with connections, then you start to get more specialist, a lot of specialist woodland biodiversity won't live in a small block because it's kind of all edge, and then the species that like to be on the inside. And very often you're right that kind of unremitting blanket of trees with no gaps in, that's not particularly great habitat, and that's why, as you see felling going on, you'll see them being broken up, and they'll have areas in between them and bits of broadleaf here and there to kind of break them up, because that's actually where you start to get really interesting habitat, is those internal edges. And if you have a big area of forest that then with sort of breaks in it, clearings and open areas, then you get these internal edges. So we might sort of, how do you balance that in a farmed landscape? Do you have farms that are then actually on the internal edge of forested landscapes? Do you have kind of networks of forests running around, running through landscapes? How do we balance these different land uses? And I think it will be different in different, it gets to a landscape scale.
Yeah, that's the tricky one with the sort of landscape scale, not necessarily conflicting, but having to encourage cooperation if you want a landscape scale sort of plan. So it's a tricky one.
Yeah, there's a lot of talk and push at the moment, a lot of interest in the loose term rewilding. I don't like the term because personally, because everyone's vision is slightly different. It's very poorly pinned. But even when you're talking about establishing forests through intervention, that can be rewilding if you're doing it adjacent to an existing woodland, and your intervention is to disturb the soil to encourage trees to be recreated. Because without some form of intervention, it won't happen. It's very unlikely in managed grass sward that trees will grow if you just remove grazing. The other reason in Scotland that's very unlikely is because of deer. And we have far too many. And they particularly like eating trees. Unfortunately, particularly the native ones, they're really palatable. So in terms of new woodlands and managing the biodiversity crisis, in order to achieve some of the ambitions for new woodlands, in actual fact, we have to tackle the sticky issue of far too many deer in the landscape.
Yeah, there is definitely a wicked problem when you're talking about adjacent landowners and different land uses and conflicting interests. So yeah, that's another debate for another day, I think. That
Absolutely.
One. Let's not open that can of worms. We had another question from Paul Gill. If you're with us, Paul. I don't know if Paul had some connection issues earlier. Perhaps he's having some trouble. We'll come back to you, Paul, if you manage to reconnect. We have an anonymous question, so I'll read that out rather than try and guess. Hi, Mike. Thank you. Really interesting. Apologies, I'm not sure I can unmute two contradictory questions. Concerns for the phosphorus increases from new plantations, given that none of our rivers in the UK currently have good standard. How will that be addressed? And 2, will we be supporting new timber industries like CLT, cross-laminated timber production? I believe all is being imported, which I understand can take cheaper linear sections of timber. 2 questions for you there.
So I'll go with the second one first. Yeah, Napier University and Forest Research have got timber properties research programs. We have cross-laminated timber being produced in the UK, I-beams and the like, which can go into construction using, as you rightly point out, lower stress graded timber. So if you haven't grown a tree that you can just use the centre bit of the tree as a roof truss, you can engineer it from lots of bits of timber, and it'll be probably even better with some good glue. Not my line of research, so that's about as much as I can say on that subject. Concerns about phosphorus increases from new plantations. That one I'm not quite so sure about. Certainly, there's very little if you were creating woodlands on current agricultural lands, you'd have soils which required no additional remediation. If you're restocking felled forests where you've got soils with poor phosphorus and you're putting the next generation of the productive forest onto that landscape, you may consider some phosphorus application. If this is a runoff as a result of felling and just that washout of nutrition, well, it's a difficult trade-off really, because we're trying to avoid a beetle that likes eating young trees and lives in the stumps of the old ones. So there's different ways of managing the beetle. The beetle emerges from the stumps after 12 months. If you plant your tree, then it'll eat your tree. So you can use an insecticide to kill the beetle, but we're trying to move away from the use of insecticides in forestry. Therefore, you leave the forest for a few years, that area that you felled for a few years, to let the beetle emerge, disappear somewhere else, plant your tree, it doesn't eat it because it's not there. In a nutshell, the issue there is all of the nutrient capital that was in the green foliage that the machinery has left on site has disappeared. And that's probably what you're talking about. So there's very difficult balances to be struck, and I don't know that there's a right answer. Eleanor, have you got anything to add?
Well, I think it's just you mentioned earlier that we were talking about soil carbon and agricultural soils versus trees, and that there's orders of magnitude difference. And I think again there's orders of magnitude difference between the both fertilizer and pesticides that are used in forestry compared with agriculture. So I think the kind of this is where I'm really interested in regenerative agriculture. I think there's some carbon gain, but I think there's huge water quality and biodiversity and soil quality gains, and that really it is obviously it's important with timber, and it's important because it's often higher up the catchment and it's on a big scale. So it's not to be underestimated. And also a lot of the trees that we planted 30 years ago are all maturing now. So there's a lot of felling going on. So there's a lot of disturbance. So it's not to be underestimated, but I think it could become a kind of distraction from either how do we resolve those issues of pollution, and how do we, should we be planting more trees?
Yeah, at the farm level, that's a really interesting point, because if you plant riparian zones, the trees are going to capture a degree of nitrate and phosphorus runoff from the agricultural component, because they'll suck it up, they'll enjoy it, and they'll grow better. Yeah. And if you have a poultry house, you have ammonia emissions, or a pig house, and the leaves will capture that a proportion of that ammonia and stop that being deposited into the water streams as well eventually. And so really it tends to be positives rather than negatives. I think you might refer, there's been some issues with prior conifer plantations being planted too close to watercourses. When you fell them, you get some issues there. But the next phase of the design tries to overcome that practice by having a different design. I hope that answers your question.
10-meter buffers in the challenge in forestry is you're working with what people did 30 years ago. And so we've had 10-meter buffers to watercourses in forestry for 25 years, but we're still cutting down trees that were planted 30, 40 years ago, so they don't have 10-meter buffers. And there's struggling to do much about that. And there's riparian buffers. I've been involved in a very interesting Scottish Wildlife Trust project called Riverwoods, which is looking at creating the same kind of riparian buffers in agricultural land, and having native broadleaf trees and undisturbed zones on watercourses in farmland, and thinking about how can we engage business and do some kind of offsetting or catchment investment project to create those kind of buffers in all cultivated land, not just timber growing.
I think we can try Paul again. Been having trouble unmuting, so let's see.
That seems to have worked. Thank you. Can you hear me?
Yep.
Yeah.
Okay, I have a question about wind farm habitat management plans to encourage golden eagles away from the wind farm footprint that, perhaps surprisingly to some, is designed to compensate for the loss of foraging habitat within 500 meters of turbines, rather than to reduce collision risk, because collision risk is largely negligible for golden eagles around wind farms. They avoid them by a variable distance. Now, these habitat management plans, of which I've designed the first, that is a whole estate, radical and broad-ranging habitat management plan, rather than the extremely simplistic measure used by, for example, MacArthur Green and every other leading wind farm environmental consultancy, including MacArthur Green's and others, for example, Arcus, now part of ERM. These are the wind farms to the north, south, and west of the site on Kintyre that I've been working on since 2009, which received a planning consent only after a protracted public inquiry, where golden eagles and the black grouse and avoidance of peatlands and groundwater dependent terrestrialist ecosystems was not an issue at the public inquiry. But a planning condition requires a habitat management plan because it's largely been copied and pasted from the recommendations from MacArthur Green, ERM, Arcus, and others. Now, the first aspect to my point is that by felling conifers, as very capably demonstrated by Mike, there will be a loss of carbon beyond that if the trees were left there, both from their removal and from the soil disturbance on peatlands. So my radical habitat management plan for this particular estate, which lacks any conifers, so it wasn't an option for us. All the surrounding estates are interested in wind farms or are otherwise not interested in being part of a habitat management plan involving conifer felling, rightly so. But there are 4 estates that are building wind farms on peatlands surrounding our conifer-free estate. So I have proposed the following. Replacing some sheep grazing. We all know that sheep grazing is not the same scale that it was in the 90s, and sheep numbers are already modest. And we can't remove all the sheep because there's land management payments that would disappear, but they can be reduced and replaced with the more lucrative cattle payment, the hill suckler premium, which is the core of my proposal. There aren't many deer, but we may have to use a little bit of judicious fencing or perhaps even some biodegradable tree tubes. We're going to encourage woodland regeneration because we know deep down, and there is some aerial photographic evidence to suggest that prior to the conifers, there was broad-leafed scrub growing on wet heath and even partly on what might be described as deep peat. And in these areas, we're going to engage with Scottish, well, Nature Scots, very generous and very well funded by the Scottish government, peatland restoration grants. We're also going to reintroduce mountain hares from Invercald Estate, where they were shot so shamelessly, along with Inverarn and Inchrory to the north in the Cairngorms. Those need to be reintroduced in the same way that beavers that are being shot in the Tay area. There's a strong lobby for them to be moved to places where they're welcome and fit. And there's a few other elements, but those are the cores. We're designing a system to encourage black grouse, red grouse, and the red grouse are obviously going to be managed by mowing. We've found a Robertson flail that will cut the heather to encourage the grouse, red grouse, and we'll cut the millennia to reduce its vigor and prevent any form of post-burning increase in purple moorgrass, and also to cut bracken so that we don't have to import pigs to do it for us. I would really value both Mike and Eleanor's thoughts on whether this is a more sustainable solution for what is going to happen anyway. With our carbon targets, we're going to have 2 or 3 times as many onshore wind farms within 10 years. And that is the primary mechanism, apart from offshore wind, which I've worked in for 18 years, solution to our net zero ambitions. I value your thoughts, Eleanor and Mike.
Right.
Sounds like a brilliant case for coming to Galbraith for one of our natural capital assessments.
I'd be delighted to take you up on that, and we can work on it together. I'll email you about it shortly, Eleanor.
It is, yeah, it is, and that's as I said, it's great to be working in a company that we've got foresters and estate management and renewable energy working alongside each other, yeah, I'm in the middle pulling people together, but that those kind of detailed questions are not my expertise, and it would all, yeah, it's as you say, there's going to be a lot more wind farms as well as more forests and more peatland restoration, and how do we fit them all together? So it's very much something that we're looking at in integration. What do we do with the uplands?
Thank you so much. I'll be in touch. And what are your thoughts, Mike?
Well, I think as you've described, as best as I could keep up with your site,
I could have slowed down, of course.
The integration of the different aspects seems sound. I think not the rush, the interest in wind will continue, as you rightly say, but I think increasingly it'll be delivered offshore.
I agree on that.
So
it's very clear that Scottish Renewables are lobbying hard for a doubling of the target, a relaxation of planning permissions, not allowing 200-meter high turbines on landscape grounds. And I predict there will be a doubling of onshore wind within 10 years.
That's interesting. I would imagine
territories.
That's interesting. I think if they got the dispensation on visual impacts and height, that actually we'd have a huge repowering of existing good sites, and not a doubling of the number of sites.
No, both are necessary. Neither are sufficient, and both are going to happen. I've discussed this with Chris Stark, and it's clearly the agenda going forward. A doubling of onshore wind, including within Golden Eagle territories, and therefore there will be vast numbers of conifer trees felled if MacArthur Green, ERM, and Arcus continue to have their way.
Well, okay, I'll keep my eye. I think the other thing in terms of the much more national picture of decarbonisation is that at the moment we don't have an effective store for excess wind energy, and so
battery projects are now almost compulsory. The project to the west of us, of the estate I'm working on Kintyre, has integrated wind, solar, and large-scale battery storage.
Yeah, that's the way we have to move.
The intermittency is history already. We're getting a battery put on our own home in Belerno in southwest Edinburgh to go with our air source heat pump and the photovoltaics, which will store, along with our electric car, the surplus electricity. Then when vehicle to grid payments, replacing the FIT and the smart export scheme, it's a no-brainer.
Yeah, I think eventually that integrated network with electrified transport providing a huge storage battery.
Got it.
That's where we've got to go. Sorry, we're digressing from forestry here, but it's always interesting.
So what about the land use implications of felling conifers? I'm told by some developers that every time they do one of these habitat management plans felling conifers, there has to be a compensatory planting scheme. How does that work? If you fell, I don't know, 500 hectares of conifers for a wind farm scheme, how many conifer or other hectares need to be planted as compensation for that felling?
There's a discussion with the local forest authority as to an acceptable response. At the moment, there is no calculator.
Okay, that's good to know. So it can be negotiated. Equally, local stakeholders can influence that discussion.
Yeah, because it's through a consultation process.
You got it.
I think the ambition of the compensatory woodland planting was also to try and shift the understanding from the wind farm developers that it's perfectly reasonable to consider replanting and managing a subsequent woodland to a height that's non-intrusive and use that material for the wood bioeconomy.
That's fascinating. I'll drop you an email if I may, Mike. We can
no problem.
You can introduce me to your colleagues. Are you in the James Hutton Institute? Sorry, are you in touch with James Hutton Institute?
At Forest Research.
Forest your Forest Research.
Yeah.
So this is a discussion that the James Hutton Institute must already have a major role in.
Mm-hmm. Okay, thanks, Paul.
Thanks for your patience, guys.
We've got one more question, if we can go back to the landscape scale discussion from Jenny Cowan. You there, Jenny?
Hello. No, it was just I was really interested in you guys's opinions on landscape scale forestry and how you make that work in Scotland, where it tends to be, well, in this part of the world anyway, lots of small land holdings, small family farms. And I was just wondering, we've been working with SLE in their wildlife estates, and they've kind of used the wildlife estates brand as a springboard for lots of land managers in this area coming together to create a landscape scale wildlife plan. And I was just wondering if there's any sort of landscape scale forestry springboard that could start discussions with lots of smaller landowners and land holdings to create something bigger.
There's a name and I can't remember what the acronym stands for. Give me a second. Have you got anything to add, Eleanor?
Not very inspired. I was going to say I'm watching with interest because we cover England as well, and how their new farm schemes, environmental land management is going to develop. And I think Scotland is kind of watching with interest. And they've got three things. They were called tiers, and then COVID came along. We couldn't use the word tiers anymore. So they've got a sort of farm scale payment for kind of basic environmental management, which is coming in next year. And then they'll have an enhanced kind of environmental management thing, but then they're going to have a landscape scale one, and that's going to be very much about group areas, places, catchments, getting together and coming up with bigger scale projects that then will be funded. And And I have the details of that bit, that's kind of third down the line. So details currently are fairly hazy, but they'll be coming in. It's due to be launched in a couple of years, so it should be coming in next year. So it'll be interesting to see how they do it. They've put a lot of thinking and resource and testing and trialing, and yeah, there's been a lot of thought has gone into it. So it's worth watching.
I think from a philosophical level, you're going to have targeted payments, which I'm sure landowners are not going to be too happy to hear that, but I can't see another way of delivering it. You know, intellectually, I can't see another way of getting to the point of implementing the land use change that's required. I do know that within Scottish Government research, the RESAS group, which includes the James Sutton Institute, where I do collaborate and have a desk, they have regional land use pilots as part of their next 5-year science strategy. And so I think that's probably, I don't know a lot about it, I think that's probably a way to try and deliver catchment scale advice and underpinning. So maybe check if there's a regional land use pilot planned for your region. That might be a way to sort of to be proactive in that engagement.
Yeah, that sounds great. Thank you.
Great. Well, I think sorry, I think we've gone from high level, broad brush scale down to the farm and back up again, and definitely covered a lot of ground today. So thank you both Mike and Eleanor for all your wisdom and some interesting discussion. I will just share my screen one last time before we go. There we go. So we'll not ask the questions again. And just to signpost a couple of resources through the FAS website. So mentioned earlier, you can apply for a funded carbon audit through FAS. So if you go to the Farm Advisory Service website, which has had a little facelift recently, so it's worth having a look on there anyway, and search for carbon audits, you'll find the information there about how you apply for the funding, and that can help you not only get a better idea of what your business carbon footprint is looking like, but also that kind of translates to efficiency improvements and where you could be improving what you're doing. So definitely worth looking at. And there's lots of other resources on the FAS website to do with carbon, especially advice on getting involved in carbon funding, which Mike alluded to earlier. So Farm Woodlands sits under Crops and Soils on the webpage. And also a quick plug for FAS TV, which started a few months back, but if you haven't seen any of the episodes, it's a half-hour program that comes out once a fortnight, and all the past episodes are available through the FAS website and also on the YouTube channel. So worth having a look at those, lots of different farming and agriculture and forestry topics covered there. So keep an eye on FAS TV. And the last thing is to say, keep an eye out on your inbox. The next day or so, you'll get an email asking you to fill in a feedback survey, and we would very much appreciate if you could complete that. Not only because you have a chance to win a £50 voucher for either Dan Delis's Butchers or the Battlefield Bakery. So if you weren't hungry and missing your dinner already, you will be now. But your feedback really helps to guide FAS in the sort of direction that is most helpful, what kind of content you want to see and how we could improve. So please look out for that and do that. So thanks again to Mike Perks and Elena Harris and everybody for taking the time to join the webinar tonight and ask some really interesting questions and prompt some good discussion. So I hope you've learned a few things, and remember that the FAS website is always available, and you can always ask questions directly through the FAS advice line and an email address. So thanks again and have a good evening, everyone.